Hello guys, in the previous video we managed to solve the day 9 part 1 of Advent of Code 2024, and in this video let's continue the part 2. And without further ado, let's jump to the problem. So what we have. So in the previous part 1 we needed to rearrange the files in the disk and calculate the new checksum for it. And then in the part 2, upon completion, two things immediately become clear. First, the disk definitely has a lot more contiguous free space, just like the Amphipod Horde. Second, the computer is running much more slowly. Maybe introducing all of that file system fragmentation was a bad idea. The eager Amphipod already has a new plan. Rather than move individual blocks, he would like to try compacting the files on his disk by moving whole files instead. This time attempt to move whole files to the leftmost span of free space blocks that could fit the file. Attempt to move each file exactly once in order of decreasing file ID number. Starting with the file with the highest file ID number, okay. If there is no span of free space to the left of the file that is large enough to fit the file does not move. The first example above now proceeds differently. So we have it first like this, and then the back of 9s will move here. Then the back of 7s will move here. The back of 4s will move here. And then the 2 will move here. Okay. Makes sense. The process of updating the file system checksum is the same. Now this example checksum would be 2858. Start over now compacting the Amphipod hard drive using this new method instead. What is the result file system checksum? Okay, so let's start by connecting the runtime, and let's clear the outputs a bit to clean the notebook a bit. So what we need to do, so we have the input is the same, we can use the same example, and so we can maybe start with that. Then we want to do the same thing here. Instead of using disk map, let's use example here, and I think we should have, yes, that looks good. So we are in the starting position where we should be. And then this is the logic where we reorder the file blocks, and maybe we could actually add a new day 9 part 2 section here and copy this so we don't need to modify the original one for the part 1. So this, what this does, it runs through the file blocks and then tries to rearrange them to the positions or prepositions. I'm thinking that is this actually the kind of most optimal way to do this, or should we go with something else? So let's actually copy this as well here. I'm now wondering, should we, instead of having list of every item like this, should we have instead an item and then how many times the item is there? And I think that would be maybe the best. And the kind of good file structure for that, yeah, block is fine. wondering, should we have from data class import data class? So if we would have this data class of file block, and it would contain the file ID. It would be string, and then count. So how many items we have of that file ID. And then so we know that file ID with dot its space. Yeah, this should work. So we have the example input, then we check is the index 0 or divisible by 2, which then indicates that it is a file. And if it is a file, we want to have this temporary variable called current file block. It can be set to none, or as we know that it's yeah, or maybe it's okay to be none in the beginning. And then here for ID range item, actually we don't need that because we know that file index is that one. Okay. So we just change this so that we will create the file block, and we can give it the file ID of string file index, and then the count is the item, and then actually we can just call file blocks append already here, and we can remove this, and then I think we should be okay with this as well. File ID, this would be just the dot, like this. Isn't it data class? Data classes, import data class, yes. Almost. So yeah, now we have the same thing, but in different kind of data structure. And now we can easily find the first free spaces we have available here. Then we can move to the next step. So file blocks are slightly different now. I guess that is okay. So we loop through the range of length, file blocks length. and we then check that. Yeah, I guess we need to do this so that we can be sure about the order. Let's see. So we check that is the file. This is the file block, and then space index. So if the file block dot file ID is that, and then file index offset. Yeah, this we need to actually, maybe we should refactor this completely. So instead of having this, or maybe actually we can make this work. So this is file block 2. We check that file ID again. And then we check the file index. That is not in the sense interesting, but we actually need to, yeah, we need to actually change this a bit. Let's have this kind of as a comment here, because we need to, as it said, attempt to move each file exactly once in order to decrease file ID number, starting with the file with the highest file ID number. So we need to start from the end. So let's start from the end. Or I guess just file block in reversed file blocks. So now we are going from the back to start, and what we need to do is check that is this space, if file block file ID is space, then we will just continue because we want to move just the files. And then we have the file block that we want to move. So we need to loop from the beginning that where exactly there is still free slots available. For this we want to loop through the copy of the file blocks, which we will modify also. So file block file block 2 in file blocks, and we want to here check it that is it space. So file block file ID is not space. If it's not space, then we want to continue. And after this check, we know that we have the space block. Maybe we actually could rename this to be space block. And now what we need to do is to check if space block dot count is more or equal to file block count, or actually we want to here check to keep the code a bit simpler. We want to check if it's less and then continue. So here we know that we have a space block, and the space block is big enough to take the file block. So now we want to switch these around. And now I'm thinking that did I make it a bit too complex with the data class, but let's see. So what we want to do is we want to now actually we maybe want to have the index also here available so that we can switch the positions a bit easier. And what we want to do is that we know the size of them both, so we need to calculate how much space there is left. Actually, we want to also know the index of the file as well. Or we need to know it. So space left, we want to calculate space block count minus file block dot count. And then we want to do so that in file blocks we will get the space index and set the file block to be there, and then we want to do the same for this file block. This actually goes quite close what we had. Actually, for this we need to check. So is moving the file block to the space, that's pretty straightforward, but now we need to check if space left is not 0, then we need to do additional logic. So first of all, we need to add the create a new space file block of file ID and count, which is space left, and then we need to add this in. So basically let's do this, and then for this we need to add 1, because we know that it will be the next one. Or actually, I think we need to did append take, let's see, insert. Okay, let's use that then. Insert, and then it took first the index, which would be the space index plus 1, and then it would take the new space, and then we would need to, for the space block itself, we would need to adjust the count to be just the file block count. So now we have this exact situation here. So we have initially the 3 spaces. We populate 2 of them. We check here that, okay, space left is not 0. We create a new space item, which will have the space left as an count, and then we insert it there. So we should have this space still here, and in the end, we should just add 2. And actually, I think we can run this. We can actually, I think, clear this comment up. Or what did it have? It had here, it had break. Yeah, that's a good idea to have. And then maybe in the next one, or no, actually, we don't need the another one. I think this break is okay to have. Then if we run that, cannot unpack non-iterable file block object. Aha, yes, we need to reverse enumerate. And this actually causes us that file index is not good, but instead we need to update it. So calculate it like this, as we had here. And if we now enumerate it again, I think we should be good. File index offset. So basically, we want to get it length of file blocks, yes, minus space index. That is the file index that it should be. Or is this actually correct now? So we add that thing in there. Actually, yeah, like this. Now it's correct, yes. And then if we check the file blocks, we should have something quite interesting, actually. This does not look good. It's not right. I guess this file index let's see what is the file index. I'm wondering that. Is it? It's 18.8.4. Actually, yes. I think we are now over doing too much work, because we need to loop the files through, but we want to move them forward only when basically yes. Okay, so we want to move them forward, but yes. These won't move because there is no space, even though the space would be there after these have moved. Okay. So what is... Let's actually print also the file block to give some an idea. So we are moving 9, then 4, then 2, and then 0. The 0 is interesting one. We need to check that one. Why? But actually, here we need to check also one additional thing. Just realized we need to check is the file index. If file index is smaller or equal than or smaller than the space index. If it is, then we can break this, because we need to just check that where or is there a space left side of the block. And then space left, yeah, let's check that one. But before that, actually we could run this already. Now it checked only 9 and 4. Let's run this. Okay, now it looks slightly more better. I can see that the space is not there as it should. Space left. Let's check that value as well. 0. Okay, space left is... Okay, now I'm wondering what is the space block here, or which one is it? We should have space block of 3. This is also interesting why we have count of 0 here. Actually, let's check that this initial data is correct, because I can see that there is some interesting things. So that is correct. This is correct. Then 3 spaces, yeah. Number 2, then 3 spaces, then 3, then 1 space, then 2 fours, then 1 space, then 4 fives, then 1 space, 6s. Then, aha, okay. I think we can then actually check here if item is 0. We don't necessarily want to add it in. So now if we run this, we should have a bit cleaner. Okay, let's see then, will it change the result? Yes. And now we have a bit different looking setup here. Yes, wonderful. So the first one is file block is file ID 9 count 2, correct. The space block is like this. So if we then print the blocks, so it has the zeros here, like that. Then it, so are we going here ever? No. And why is that? I kind of feel that we are... Maybe we need to do it like that, and then... Yeah, now we are going there. I think I actually know the issue. But we need to do file blocks, file block count. So we loop through the file blocks. Then when we find a file block, we locate the space block from left to right. Then actually let's check the file blocks. Okay, that looks good, but why then this does not work? Interesting. Yeah, let's see. So we look through the file blocks. When we have a file block, we look for space blocks. Then we check is the space block big enough to fit the file block. If it is, then we will continue. And then we will check the file index. This is something that I'm kind of also interested in. Because it says here 17. So do we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, it starts from the last. Then it moves to so it won't even add the... This is like the interesting part that I'm kinda... okay, now I know why it's... I noticed that the length of these spaces have changed, so it is this that kind of ruins the thing. So we need to just get the copy of that. So let's have space block copy of space block. Let's distinguish the name with that underscore. There, yes. I think now we should get it constantly running. Yes, good. Now it actually seems to be working a bit better. Wonderful. And how our answer, by the way, looks. So we have 0, 9, then 2, then 1. It's not yet there. It's not yet there because there is this. Okay, why? So the file ID 7, it comes, So it's basically this. It's 8. We know that, oh sorry, this one, 14. So we know that there is exact amount of space in position of, maybe we should add the space ID here as well, just to, or space index, just to keep track. So it's 4. Let's see, I think it's correct. So 1, 2, 3, 4. Is it 4? I doubt it a bit now. Space index. It enumerates through file blocks. And oh yeah, sure, it might be actually, because we need to, let's print the file blocks as well. Yeah, it was here, but let's print it before as instead. So it says that it's 4. So we have file block, then we have another file block, then we have a space, then we have a file block. So we have 1, 2, 3, and then 4. Okay, correct. So it should go there. And let's actually print also the file blocks afterwards. Let's add some print here to give us better visibility on the iterations. So how did it go? It replaced that. So it looks good. And then what happens? This should go to 6th. So I'm wondering why we are ending up into this situation if we can see that. Yeah, the last round is the kind of the problematic one. So it clearly does something. Oh, do we have duplicated 7? Actually, this is interesting. So is the removal? Okay, so when we introduce new, wonderful. So file index, this file index is not actually, okay, this is not correct. So what we need to do, or we can just loop the file blocks through, check if it's not space. Then for the file index, we need to go through the list and find the position of the file. or none, and then so we need to look through the items in the index item in the file blocks, because the position might have changed. So if item.file ID is matched to file block dot file ID, then we set the file index to be index, and we will also break. Oops, enumerate. Yes, that as well. Okay, now we have a very different. So it should, so it says that it's starting from file block 7, which is not correct. It should start from file block 9. Let's check this one. So what is the file index here? 17, 16, 40. What's going forward? And then actually, this is something that was it modified somewhere? Kinda, yes. So we want to maybe copy this as well. Or not sure. Now I'm wondering why it's, because we go forward and then until we have, oh, yes, this is causing it, yes, most likely. Yes, okay. Now we actually have quite good looking thing. And if we compare it, okay, we have still some issues of deletion. So we need to, okay, so if we introduce new, then this file index is also something we need to increase. That is very true. Or can we do it here and then actually leave that off? Yes, okay, now it looks a bit better. I think it actually looks correct. So we have the 2 zeros, then 2 nines, then 1, 2, then 3 ones, then 7, 3 times, then we have a space, then we have 2 fours, then space, then 3 threes, then different amount of spaces, but equals, it should equal to 4. Yes, correct. Then we have a 5, 4 times, 1 space, 6 4 times, 5 spaces, correct, 4 eights, and then 2 spaces. Okay, looks good. Then let's try to calculate the checksum. So this was the checksum calculation logic that we used last video, or in the part 1. So we need to now just modify this a bit. So if file block file ID is that, then we continue, then we check the index, And for this file ID, we need to access it like that, and then we print the checksum. It did not calculate it correctly, or at least I feel so. So how to call? Yes. So we can do it like this. We need to have a for loop here. For I in range 0 to file block dot count plus 1, and then we do the calculation here, and I think it should be now close, not exactly. Do I have like too much? No. So 2858. Let's revise the checksum calculations. To calculate the checksum, add up result of multiplying each of these blocks' position with the file ID number it contains. The leftmost block is okay. Yes. So we need to index this plus equal to file block dot count, and then we can proceed. And then here, I think this should be okay. Yes, that was it. Okay, cool. So we managed to get that result aligned very well, so we can then check with the actual disk map. And we got the result. Then scroll to the day 2. Disk map. Yes. We got those. Quite nice file blocks. Then we'll run this one. I think this will take a moment or two. Maybe those prints could have been removed, but let's see if it matters too much. Let's clean this up a bit just to speed up the execution. Let's leave the file index there so that we can kind of follow the progress a bit. But otherwise, I think we should be good to run this. I'll speed this up so you don't need to wait for the long time. Yes. Now we have all the calculations done. We can check the file blocks. Looks that we have items there. And let's check the checksums. And let's just print the latest value, which is this. So let's try. Is it our result value? Yes, it is. Nice. So this was day 9. The task was quite interesting. Nice small puzzle there. And I think it's good to pause here so that the video won't get too long. And see you guys in the next day 10 challenge then. But thank you for watching, and if you like the video, drop a like, subscribe the channel, and see you guys in the day 10 challenge then. See ya.